Okay, today we're going to start with a review of a linear regression. I'm going to give you some numbers to put in for x and y. Let's say x is the length of the pinky bone that was found, and let's say that that correlates to a person's height. And the length of the pinky was, let's say, a 1 centimeter pinky went with a 50-inch height, and a 2 centimeter pinky went with a 90-inch height. Is there an exact correlation? No, otherwise it would have been a 2 with a 100. And this is the entire pinky, by the way, not just a little part of the pinky. This is the entire pinky bone. Okay, so a person could have a 3-inch long pinky, and let's say that that makes them 140. All right, I'd like you to, these are ridiculous numbers. I'm making them up in my head, but the point is, put those numbers in the calculator, do the linear regression thing, and I'd like you to predict what a length of pinky of 2.5 would be. Now, if you try to do this on a chart, you better change your table settings on your, table. If you want to go to your table settings and have it count by halves instead of count by wholes, that'll make it work. Okay, so what I'm asking you to do is find the linear regression equation as the first part, and then use it to predict how tall the person would be if their pinky was 2.5 centimeters long. I want to pause for a second while you do that. Okay, I was just verifying that kids knew how to do second calculate intersect for this equation. We would start with these two equations, and we did second calculate intersect. Second calculate intersects the fifth one. And then if I want to get to the other one, I go, first two questions are first curve, enter. Second curve, enter. You always hit enter, enter. Then the last one is you move over by the spot where they intersect and hit enter, and it'll jump to that answer. If all you know how to do is hit enter, 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 you'll only be able to get one of the answers. You won't be able to move to the other answer. It's enter, enter, and then arrow over for the guess part. Okay, enough of that. Now, if I gave you this equation, do you know how to graph it on your calculator? Everybody, you're going to have to change your window a little bit, or you won't be able to see 18, because your graph only goes to about 10. So make sure when you graph this puppy, you change your window so you can go high enough to see 18. Second calculate intersect again. I'm going to pause while you work on that one. I want you to just compare the answers you get to the person sitting across from you that I assigned you. Okay, we're done with that one, and it came out to 12 and -6 were the two places. I can kind of imagine what this would have looked like. 18 runs across like this, and if I know that 12 and -6 are the two places it hit, was it 12 and -6? Okay, then let's say here's 12, and -6 should be like, let's say here. Then I just have to go up here and know that it touched like that, right? And then my next thing I could do to like kind of guess where this graph would be is find the Y-intercept. Fill in this sentence for me. The Y-intercept is where? What? X equals 0. Very good. You need to know that. That's why I taught it to my kids last year. Why? The Y-intercept is where X equals 0. If you stick a 0 in here, wait a minute. The Y would have to be like this, because I'm setting Y equal to this. So X equals 0. So then I'd have -6. So I know it touches at -6 down here. So anyway, bottom line is, I know the graph looks something like that, and I got two places that it crossed. Did you have those two places crossing, generally? What? No. Nope.
Yeah, it's at 0.
But, okay, just to answer her question, do you get you've graphed two things? Here's Y1 and here's Y2, and it doesn't matter which one's which, but that's one equation, that's the other equation. That's what you should be graphing, those two equations. And where they touch, generally speaking, you have a V shape, and I don't know exactly where the bottom of the V is, but I know this is part and this is part, and it touches like that. Am I generally right on that? Okay, good. All right. That's what you were looking for. That's what you were hoping to have happen. All right, moving on. What if you're not allowed to graph it? Then you have to do it by algebra, and that's what we learned yesterday. A lot of times it'll factor. So like for instance, it factors to this. Then one question I get a lot is there 3 answers? One for this, and one for that? No. There's no answer for the 2 because you can't make that equal 0. You can make this equal 0, you can make that equal 0, but you can't make that equal 0, so there would only be 2 answers in this case. What happens though if there was an x out there? Can you make that equal 0? Then there would be an answer for that one. Then you'd have 3 answers for that kind. That's a common question that I get. I wanted to clear up. All right, I'd like you to take a minute and load up your worksheet that is for today. I'm going to pause for a second when we all do that. Okay, so last thought on this for the recording here is when you get to like a problem like number 4 on today's worksheet, don't try to solve that and then graph it. You don't need to do that. You just can graph it right off the bat. You graph both sides of this. You graph the left side as y1 and the right side as y2, or vice versa. It really doesn't matter. Once they're both in the calculator, you see where they cross. Second, calculate intersect. Don't try to solve it first and then graph it. All right, I'm going to look a little further down on the worksheet, just make sure there's no killers in here. Do you guys know how to use put in a square root on the calculator, like number 5 or number 6? If you don't know how to put in a square root, I suppose I should show you. If I wanted to do square root of 3x minus 2, like that problem 5 you see to the left of the calculator there. Square root of 3x minus 2. How do I put in square root? It's right above the x squared. There's the square root. Right above the x squared. I'll leave it red for a second so you can see. Right above the x squared button. And then I just go 3x minus 2. There we go. And then to get out of from underneath the square root, I'd have to arrow over. Now I'm out of the square root. There it is. And then I'm going to, wait a minute. Equals x. Oh, okay, so then I put an x here, not a 0. There we go. Equals x. And then I would just hit graph. And I see where my 2 lines cross. And it's really hard to tell where they cross, but that's what the calculator's for. Second, calculate intersect. And enter, enter, enter. All right, something is wrong. I'm going to pause for a second while I figure this out. Okay, I want to see this area better because I can't seem to find where those 2 spots cross. So I'm zooming in with the zoom box. And I've zoomed in now, and I'm going to see where those 2 lines cross. It sure looks like they cross to me. I'm going to try it again. Second, calculate the intersect. Enter, enter, enter. This time it jumped to it. That's weird. It wouldn't jump to it before for me. But when I zoomed in and I could see where they crossed, then it played nice. All right. So that's one spot they cross. Is there a chance it crosses again? Yeah, as I look closer, it looks like there's another crossing to the left a little bit. So I'm going to go second, calculate the intersect, and I'm going to go enter, enter. And remember, it's the third one is the charm. The guess one, move that over and see if there's another spot over here where I think it looks like they cross over here. And I hit enter, and it'll tell me if there's another spot. And there is at 1, 1. Okay? So sometimes the calculators can be a little fussy. If you're having trouble, zoom into the area you're really focused on. I use zoom box. Some people like to use zoom in, but get it zoomed so you can see where they cross. And then try your second, calculate intersect again. All right, this is the part where I got to answer some individual questions. So for today, it was, if you haven't noticed, it's pretty much a review of the other day we had of graphing. There is enough problems on here that I think we should skip a few. My classes, I'm going to allow you to skip 10, 11, and 12. You may cross off. Are you listening? You're missing something important. Cross off problems 10, 11, and 12 from today's homework. And then I want to help you with number 13, just so some people have trouble with the word problems. We had some of those on the other day's homework. And if hopefully you looked at how they were set up and got a feeling for how to do it. But we'll talk a lot more about word problems later. For right now, 9 more than a number is written. Pause for a second here. Okay, so I'm supposed to be translating problem 13 here. And it's, how does it start again? 9 more than a number. 9 more than a number. I have a number and then 9 more means plus 9, right? 9 more than a number, then what? Divided by 2. Equals the number squared. Does that look like an equation to you? Can you graph both sides and see where it crosses then? Yeah. The only question really is, should I put this in parentheses or not? 9 more than a number divided by 2. I think it should be in parentheses, because it implied that I should do the 9 more than the number first and then divide it by 2. Now that's a tough one to know whether or not they really should have done that or not. But I would graph this side, y equals this, and then graph that side, y equals that. And of course you don't use n, you use x on your calculator, because there's no n variable to graph. Graphing is only x and y, so go 9 plus x divided by 2, use parentheses. Then they should cross, and wherever they cross, that's your answer. So you're just translating this into an equation. Once you got an equation, you can graph it. So this kind wasn't super hard. All right, that's all I have.